Okay, I am going to explain 11.5 today, which is multiplying and dividing rational expressions. I think I had said earlier in one of my other videos that we were going to start with adding and subtracting. We'll save that for later. Multiplying and dividing fractions is a little bit easier. So I'm going to start with a problem that is not on page 1 of your notes because I want to go back, way back, to just, you see all these A's and B's, but I'm going to write 15 over 22. Let's say I needed to multiply that by 33 over 40. Okay, so I'm going to start with just basic rules of multiplying fractions like I did in first quarter so that we could review fractions specifically for this chapter. Okay, so if you are going to multiply fractions, the basic rules for multiplying fractions are you can multiply straight across the top, write your answer, your bar for division or your fraction bar, and multiply your 22 by 40 to get your denominator. However, it's a lot easier when your numbers are a little larger or when your expressions are rational expressions to cross off common factors. We are reducing by finding common factors. So you've used the word factors and common factors since you were probably in 3rd, 4th, 5th grade when you were talking about fractions. When you're multiplying, you can reduce and find common factors up and down. So if I think about the number 15, the factors for the number 15 are 3 and 5. So maybe just write it up here, 3 times 5, right? And 1 and 15. Those would be the factors of 15. The factors of 22 would be 1, 2 times 11, and 22. Those are the factors of 22. The factors of 33 are 1, 3, 11, and 33. Factors of 40, there's more, but 1, 2, 5, 5 times 8, 2 times 20, 1 times 40. Okay, so there's your common, or I'm sorry, not common, but your factors for 40. I'm not asking you to write out all of your factors every single time. I'm just trying to explain to you what I'm doing. So you want to find the greatest common factor. So if you look up and down, and you look at this list and this list for 15 and 22, can you divide 15 and 22 by a common number? No, I do not see a number in this list that's the same as the number in this list other than 1. But if you divide them both by 1, they're just going to stay the same. Okay, so I'm going to look at 33 and 40. I could reduce this up and down if it's possible. I do not see a common number or common factor in these two lists, so I cannot reduce this fraction. This fraction is simplified. This fraction is simplified. However, when you're multiplying, you can cross-reduce. And you're going to use that quite a bit in 11.5. Okay, so you can reduce up and down. You still can do that. Or you can reduce diagonally. So now when I look at 22 and 33, the greatest common factor is 11. So if I divide 33 by 11, I get 3. If I divide 22 by 11, I get 2. You can cross-reduce. For 15 and 40, and you look at your list, the greatest common factor for 15 and 40 is 5. So you can reduce these both by 5. If I divide by 5, I get 3. If I divide this by 5, I get 8. All right, so now your new numbers, if you multiply 3 times 3, you will get 9. If you multiply 2 times 8, you get 16. And when I multiply 15 over 22 times 33 40ths, I will get 9/16. All right, so there's a bit of review. Don't forget, so I'm putting my lessons like this on YouTube. There are millions of lessons on YouTube by people that aren't me. So if you want to go back and look up multiplying fractions, cross-reducing fractions when multiplying, adding, subtracting, multiplying, dividing fractions, reducing fractions before you get into this polynomial business. Or you can watch someone else explain multiplying and dividing rational expressions as well. If my words aren't making sense, I guess sometimes someone else might. So I'm going to start with example 1. It's multiplying. Again, so many options. So I could begin by reducing this fraction vertically, right? Up and down. Not the 7/5, they don't have a common factor, but I could cross off an n squared with n squared up and down. So I could reduce that way if I chose. 10/14 can be simplified. So I could reduce this fraction vertically. I could also simplify the n to the third over n. Another reason we focused on all those exponent rules earlier. Or I can start by simplifying diagonally and diagonally. Sometimes when you make your choices within the problem and you get your answer may somehow still need to be simplified, and that's okay. So I'm going to start, I'm going to just choose what I want to do. Again, there are other choices that you can make. If you want to pause and try it yourself, go ahead, see if it matches what I'm about to do. And feel free to email me questions. Take a picture of your work. Mrs. Stofflet, this is what I did first. Does this work? Why didn't I get the same answer as you? Or do I just need to simplify my answer further? Wherever you are at. So I am going to choose to reduce diagonally as I look at these. So I'm going to start by looking at those. Kind of maybe covering the other two up. So when I look at the numbers 7 and 14, I can divide them both by 7. I'm going to do that. 7 divided by 7 is 1. 14 divided by 7 is 2. I'm going to rewrite this as 1n to the 5th. I didn't touch my n to the 5th, and I'm going to rewrite this as 2n. I'm going to continue to cross-reduce with those variables. So I'm going to cross off this n, meaning I'm still just left with plain 2. Maybe I'll rewrite my problem. Here's my multiplication sign, right? Here I said that I'm crossing off my n with this n to the 5th, and I do still have this 2 down here. I just don't want to lose track of what I have. Okay, so I just crossed off one n, meaning I can only cross off one of these 5 n's, leaving me with 4. Okay, so I'm going to explain again. The 7 became a 1. You can write a 1 there if you'd like. By dividing by 7, the 14 became a 2. There was 1 n, an n here, 5 of them here. So I crossed off 1 n. Taking away 1 n there would be n to the 4th. It did not subtract it. I'm dividing by n and dividing by n. Okay, diagonally going the other direction. Number-wise, if I divide 5 by 5, I have 1. If I divide 10 by 5, I have 2. I have n squared, n times n to the 3rd, n times n times n. I can take 2 of them away. It means they're all gone down here. And 2 of them away leaves me with 1. Okay, so I was cross-reducing. So right now you can see right here, I could still reduce this further. I'm going to go ahead and multiply straight across the top and straight across the bottom. 1 times 2 is 2. N to the 4th times another n is n to the 5th. And 1 times 2 is 2. I can continue to simplify this problem because 2 divided by 2 is 1. If I cross these off and write them as 1s, I do not have to write my problem as a fraction any longer. because I have a 1 in the denominator. Okay, so my final simplified answer is n to the 5th. I know it looks messy. If you could please, for me, when you do your work, notice I didn't scribble anything all the way out. I simply put a line through the number so I could still read the number. Okay, give that a shot. Okay, now when I'm noticing your factoring, can you look at the difference between example 1 and example 2? What do you see in example 2 that example 1 did not have? I hope you're responding with addition and subtraction signs. When I did all my random lines crossing off like this 10 end of the third was not being added or subtracted to anything else. My factoring for 10 end of the third looks a lot different than my factoring with 3y minus 3y squared. When you get to this problem here and you see these subtraction and addition signs, go back and look at the most recently posted video that I shared with you that reviewed factoring. This y in this numerator cannot be crossed off with any y's down here or down here. That y is not a factor of anything in that numerator. This entire piece, and I'm going to recommend you put parentheses around it, has to be crossed off as is as a whole. Y minus 5 is one factor. You cannot put a little line through that y, you cannot put a little line through that negative 5. If you cross this y minus 5 off, it gets crossed off entirely as one factor. I might write that. Protect it, put the parentheses around it. Okay, so if you see addition and subtraction signs, you need to think. When you see addition and subtraction, comma, think, hey, I have to factor. Factoring rules, factoring. So I need you to factor anything where you see adding and subtracting. So y minus 5, that's my binomial. If you go back and look at that video I shared, you need to think greatest common factor. So do the terms y and negative 5 have a greatest common factor? They do not. That is factored completely. I do not see any addition or subtraction signs here. That means I can cross off just the 2, or I can cross off a part of this y squared. Only because there are no addition or subtraction signs. No plus or minus can, these are just my words, can cross off the 2 or y, you know, like 2 times y times y. Okay, but I'm not going to separate this 3y squared as a 3 times y, because these two things are connected. So to factor this, I need to say greatest common factor. Okay, no plus or minus sign, subtraction sign, subtraction sign, subtraction sign, and addition sign. I will factor these 3 differently than this. All right, so binomial, greatest common factor. I can take out a 3y. I'll be left with, if I divide this by 3y, 1. Minus, this is a 3y squared, so 1 minus y. This is the factored form of this. When you are adding, subtracting, multiplying, dividing these rational expressions, I want you to think of, can I factor this? Can I factor this? Can I factor this? That already is factored. Y minus 5 is one factor. Can I factor this? There's no adding or subtracting. That's why it looks like this. All right, my factoring example, right? There's a leading coefficient of 1. If I factor this denominator, and you must, 2 numbers that multiply together to make a positive 5, and when you add them you get a negative 6. Should be 6 and negative 1. wait, I lied. Sorry about that. Should be -5 and -1. They have to multiply together to give a +5. Sorry about that. 6 and 1 don't multiply together to give you 5. Caught my own mistake. If we were in class, you could have got extra credit for that. Okay, so I'm going to rewrite that as, I'm sorry, they're both negative. -1. I gotta erase that too. Dang it. Dang it, Stofflet. Give you a breather. Alright, so this is going to have to be y minus 5 and y minus 1. I'll just rewrite it. Okay, I'm going to rewrite the entire fraction since that looks a bit messy. Rewrite the fraction. Equal sign. Y minus 5 over 3y, the factored version, 1 minus y, times 2y times y, I guess. Again, no adding or subtracting there, no adding or subtracting. It's why I can write it separate. I did not write this as 3 times y times y. I'm factoring that. Okay, now I can cross off common factors diagonally. So again, as a whole, this y minus 5, the whole thing, and this y minus 5, not in separate pieces. Diagonally, one of these y's with this y. Okay, so in my numerator now, I'm just going to slide over. I've got paper underneath this, so I'll just keep going. So this is gone. It's a 1. 2y left in the numerator. Denominator, the 3. Oops, sorry. A 1 minus y. And a y minus 1. I personally would be okay with this answer. Okay, just want you to know that. I would be personally, as a teacher, okay with this answer. Sometimes when you look in the back of the book, okay, they say, you know, wouldn't it be nice if this y minus 1 looked like a y minus 1? That would mean the y would be positive and the 1 would be negative. I could factor out a -1 to make it look the same as this. In other words, I could have factored out a -3. Which would have made this a positive y minus 1. And you would have had 2 y minus 1s. The back of the book might look something like this. Also keeping in mind that that negative sign could have been in the middle or on the 2 instead of on the 3. So a lot of things when you look in the back of the book. Some of you are showing work and then you're just copying the answer in the back of the book and like, ta-da, that happened. And I'm like, yeah, no, your work doesn't show that that happened. So it gets tricky. Ask the questions, ask the questions, ask the questions. Alrighty, so we're going to move on to example 3. See if this gets any better the more I do. Alright, example 3. Again, factor the numerator, factor the denominator, factor the numerator, factor the denominator. Since you don't visually see a fraction over here, I'm just going to write it over 1. That will be a numerator. it's also one factor. So I'm not going to cross off this 3 with any 3 over here. These are not able to be reduced. You can't cross off that -3 with that -3. They're parts of a factor. You can only cross off whole factors. This is one factor. This whole thing has to be crossed off in its entirety together. Same with this here. So I'm going to put parentheses around. Did you notice the plus sign? Okay, so that is one factor. If it gets crossed off with anything, it gets crossed off as a whole. I cannot factor this further. It does not have a greatest common factor for 2x and 1. I cannot factor that numerator any further. It does not have a greatest common factor between the 2x and the -3. I'm looking at this trinomial, and if I go back to my review that I shared with you today, it's a trinomial with a leading coefficient bigger than 1. So I'm going to try to factor it. Again, if you want a shortcut for, hey, can I factor this or not, you can use b squared minus 4ac. If it turns out to be a perfect square number, this is factorable. Well, that means you got to try to factor it. I'm going to tell you right now it's factorable. So you're going to multiply the 2 times a -3 and get a -6. Find two numbers that multiply together to make a -6 and add to a -1. And those two numbers should be a -3 and a +2. Okay, so to factor this, you rewrite the first term. You take your two numbers and you put them in the middle with an x on them, and you recopy your third term. You then have a polynomial with 4 terms. When you get any polynomial with 4 terms and you need to factor it, you will separate the first 2 terms from the last and try to continue to factor. So binomial, common factor, they both have an x. So I'm going to factor out an x. 2x minus 3. I promised you that this would look the same. Well, if it already looks the same, but you need to factor something out of it to combine it with the x, what you are factoring out or dividing by is just a 1. Because if I did 1 times 2x minus 3, I would get 2x minus 3 back again. So I have x plus 1 and 2x minus 3 as my two factors. One factor, two factors. All right, so I'm going to rewrite the problem for you. I'm just going to show you my highlight. This was my numerator to begin with. This is my factored denominator of the left fraction. This was my numerator to begin with. This is my denominator to begin with. So I'm just going to rewrite the math problem since my factoring made it a little messy. 2x plus 1, original numerator, over x plus 1 times 2x minus 3, factored denominator, times 2x minus 3 over 1. All right, there's my new math problem. So factor the numerator if you can, factor the denominator if you can, factor the other numerator if you can, factor the other denominator if you can, cross off any common factors vertically if you can. Diagonally if you can. Okay, so it looks to me like this whole 2x minus 3, remember that's one factor, can be crossed off with this 2x minus 3. I don't want to see this 2x minus 3 being crossed off in two separate parts. It's one factor. You cannot cross off this x plus 1 with this x plus 1. This is one factor. This whole thing is 2x plus 1. It does not look like this. All right, so my simplified rational expression is 2x plus 1, and you can keep that in parentheses if you'd like. The back of the book won't show it that way. I do not care. I like you to protect it over x plus 1. And that you can also keep in parentheses. By the way, I did multiply it by 1. It doesn't do anything to it, right? All right, so that should be your simplified rational expression for example 3. All right, heading to example 4. Ooh, division. Do you remember what you do for dividing fractions? Keep, switch, flip. Keep this fraction the same order that it is. Switch to multiply, remember? Flip. Keep, switch, flip. My new problem will be n minus 2 over 2n. Change to multiply. Flip this upside down. These are all in factored form already, so I can cross reduce this whole factor. There's only one factor there. With this whole factor, there's only one factor there. If I divide by an n minus 2, I get 1. If I divide by n minus 2, I get 1. 1 times n plus 5 is n plus 5. 2n times 1 is 2n. Simplified rational expression. Question for you. Why can't I cross off my n's? This is one factor. I'm going to say anytime you see an addition or subtraction sign, put it in parentheses. You cannot cross off those n's. Illegal. Okay, we are going to go to example 5. I'm sorry this looks so horrible. That is a 5x squared. This is an exponent. I'm going to rewrite it. You should too. I'm going to factor it. It's a binomial. I have to question, is it difference of squares? No, those aren't perfect squares. Is it, or is there a greatest common factor? Yes. I can divide them both by 5. They also both have an x. If I do that, divide it by 5x, I'm left with x minus 4. This is my factored form of 5x squared minus 20x. It has been factored. There are 3 factors in that numerator. Factors, things that are being multiplied by each other. This x minus 4, this is one factor. It has to be crossed off as a whole. However, this x is a factor. This 5 is a factor because this 5 and this x, they are not being added or subtracted to anything. Okay, they are being multiplied by this third factor. One factor, second factor, third factor, 3 factors there, 3 separate factors. So your denominator is x plus 5. It's a factor, not this x with this x. This x plus 5 is if not being multiplied by each other, so that is one factor. And then I have a division sign. Okay, so I'm going to keep switch flip. So I'm going to keep this first fraction, 5 times x minus 4 over x plus 5. Okay, that same fraction. Sorry, gosh, you couldn't see it the whole time I was writing. You can pause if you'd like, but I'll repeat saying that. I just rewrote what was in yellow here. Okay, as this first fraction. Keep, switch division to multiplication. Flip that upside down. Well, if it's just x minus 4, it's like an x minus 4 over 1, correct? So now if I flip that upside down, it will be 1 over x minus 4. Now if I'm thinking of cross-reducing, I can cross off this x minus 4 in its entirety because it's one factor with this x minus 4. I cannot cross these x's off. There's no x plus 5 anywhere. Okay, so on the top, 5 times x times 1 is 5x. And I have x plus 5 times 1. I cannot simplify this any further. No more. Can't simplify that any further. That is my simplified rational expression after I have divided in this case. All right, that is example 5. Example 6. Don't let it scare you. All right, says, the models below are based on data from a regional craft fair held annually since 1990. The variable t represents the number of years since 1990. Okay, so t is how many years since 1990. This n stands for the number of items that you sold. So this expression represents how many items you sold since 1990. Average cost per item. Okay, so I'm going to break this down in a much simpler problem. Let's say I'm selling suckers, okay? So I'm going to sell really large suckers for $2 each, and I'm going to sell 10 of them. This question is find a model for the total sales. Okay, so if I sold 10 suckers at $2 each, what would my total sales be? I'd make 20 bucks, right? 2 times 10. So if I have a certain number of items I'm selling, and I know how much I'm selling each of them for, you are multiplying these together. So find a model means find an expression for the total yearly sales, and we want it simplified. So I'm going to write this out as a big old multiplication problem. We're going to factor, multiply, and reduce if we need to. All right, so I have 20,000 plus 400t. Sorry, I'm going to turn it sideways and then rewrite it. But 20,000 plus 400t over 1 minus 0.03t times 850 plus 60t over 50 plus t. All right, so this is your multiplication problem. I want you to think factoring. Factor, it's like you have 4 factoring problems. Can I factor this? Can I factor this? Can I factor this? Can I factor this? Most of them look like yes. I'm going to say there's no common factor with those parts. That's one factor. And I'm going to say that I cannot factor this either. However, when I look at these top 2, I'm thinking there's probably a common factor. 20,000 and 400. What could you possibly divide them both by? If you have a calculator near you, I know you have a calculator on your iPad, but you're watching this. So if you have a calculator, see if you can divide them. Think about the 4, think about the 20. I'm going to tell you that you can divide them both by 400. 400 times 50 makes 20,000 plus sign. 400 divided by 400 is 1, but there's a t. Okay, so now this is my factored form. It looks like I have something to cross reduce, but I'm not going to do that at this time. Okay, I'm going to factor the 850 plus 60. And when 2 numbers end in 0, for sure you can divide by 10. You could try to divide, you can divide by 5, but you want the greatest common factor. 10 is larger than 5. You could try other numbers that go into 60. You could try 30. You could try 15. Dividing by 8, divide 850 by those other factors and see if there is another common factor. I'm just going to tell you that the greatest common factor is 10. So if I divide them both by 10, I will get that. This is my new numerator. These are my denominators. I'm going to rewrite my math problem. I just had to rewrite. I just wanted it not to be so messy for you. Okay, think cross-reducing. Do you also see a 50 plus t in parentheses? You have to cross it off in the whole, in all of it, right? You cannot really cross-reduce anything else. This is going to just look a little messy or be a bigger answer. So I'm going to multiply straight across the top. Your 400 times 10 will be 4,000. We still have 85 plus 6t. Okay, that's your numerator. In the denominator, you just have that, oh, cheapers. Sorry, 1 minus 0.03t in your denominator. But that is going to be your model. Find a model. That'll be your model. I'm going to rewrite it down here for the letter B. So 4,085 plus 6t all over 1 minus 0.03t is your model. Use the model to predict the total sales in 2003. Well, 2003, how many years since 1990 is 2003? 13 years later, right? So your t is going to become a 13. So I'm going to rewrite 4,000 parentheses 85 plus 6 times 13. I just replaced the t with 13 because it's 13 years later for time since 1990. And then 1 minus 0.03 times 13, because your time is 13 years later. Then you need to multiply that or simplify it to figure out your amount of money, right? Okay, so order of operations. Your 6 times 13 is 78 plus 85. 78 plus 85 is 163. I need to take 163 times 4,000. You're going to trust me on this, but you can check me if you'd like. 652,000. Ooh, my words aren't working. All right, 652,000 divided by, you need to take your 0.03 times 13. You have to multiply before you can subtract, order of operations. So 0.03 times 13 is 0.39. 1 minus 0.39 is 0.61. 652,000 divided by 0.61 is a whopping $1,068,852.46 if I were to round to hundreds, because this is money. How much in sales? Alrighty. So there you go. There's all my examples. Again, I am here for you for questions. Your assignment is right there. Please check the answers in the back of the book. Again, sometimes the back of the book's solutions or their answers. Play around with that negative sign a little bit. So if you're confused about your answer being correct, if it doesn't look like the answer in the back of the book, ask that question because sometimes you are right. Okay,